Okay, so we left off the notes yesterday talking about the product property of radicals. We didn't quite finish the notes, so I'm going to go over what we talked about, and then we'll finish with the last couple examples. All right, so the product property of radicals states that if you have two square roots, or two of any radical with the same index, and you're multiplying them together, well, that's going to equal the radical, or the square root, of the product of the two radicands. Okay, so the two things that are underneath the radical, okay, separately in the first part, can be combined into one product in the second. Okay? And we showed why that works and how it really is, since all a radical is an exponent, a fractional exponent, that it really just follows the exponent properties we talked about in the last lesson. So the square root of a times the square root of b equals the square root of a times b. Or with numbers, the square root of 3 times the square root of 7 is equal to the square root of 21, which is 3 times 7. Now, how we're going to use this property is we're going to use it going backwards. We're going to break down radicals into two products. So the example we had was we did the square root of 26, and we wanted to rewrite it as two products, two separate radicals multiplied together. So all we had to do is think of two numbers that multiply to 26. So the square root of 26 is also equal to the square root of 2 times the square root of 13. Okay. So let's look at another example. The next example is the square root of 12. So how can we break down the square root of 12? Well, you have to think of two numbers that multiply to 12. So you have a couple options here. You have 12 and 1. That's not really going to help us any. Your other options are you do the square root of 6 times the square root of 2. Since 6 times 2 is 12. Another option for 12 is you could have the square root of 4 times the square root of 3. Because 4 times 3 is 12. Okay. So you can break these down into smaller numbers. Now this first one, the 6 and the 2, doesn't really help us much. But if you notice the square root of 4 times the square root of 3. The square root of 4 is a perfect square. So the square root of 4 is actually a number. Okay, the square root of 4 can be simplified. Square root of 4 is just 2. So instead of the square root of 4 times the square root of 3, we could rewrite that as 2 times the square root of 3. And that is simplest form for this radical. Okay, that's the goal here. We're trying to simplify radicals. And to simplify radicals, you need to make the radicand, the number under the radical, as small as possible. So by using perfect squares and using the product property to break it down into perfect squares, we could simplify these into smaller radicals. So 2 square root of 3 is the simplest form of the square root of 12. So this is our simplest form. This is our goal for all of these problems. Put it in simplest form. All right, so now let's formalize this a little bit. And like I said, there's two methods that we're going to use to simplify radicals. This is going to lead us into our first method. So we'll just call it method 1. And in method 1, we're going to try and replicate what we just did. What we just found was we found a perfect square that is a factor of 12. Okay. And since we use the product property of radicals to have the square root of that perfect square, which is just going to be the number that multiplies into it, times whatever is left over. Okay. So in method 1, we're going to break down the radicand. We're going to break down the radicand into perfect square factors. To simplify it. So again, all that's really saying is we're trying to think of a perfect square that goes into that radicand. Okay, then we'll write it as two separate factors. So for problems like these, it's going to be good to know your perfect squares. Okay. So your perfect squares are, any whole number squared. So your perfect squares are 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 6 squared 36. You can keep going. So knowing those values are going to help us figure out which ones to pick. Again, going back to that 12 example, 6 and 2 multiply to 12. Those are factors of 12. However, neither of those are perfect squares. Okay? So if you have options, you want to pick the one that it has the perfect square. So in this case, 6 and 12, is true. or 6 and 2 is true, but for this method, we want to use 4 and 3 because 4 is a perfect square. Okay, so let's look at another example. All right, let's say we have the square root of 45, and we want to simplify this. We want to make that radical, the number under the radical, the radicand, as small as possible. All right, well, we need to think of factors of 45. Okay, so some of the factors of 45, and more specifically, we want to think of factors of 45 that are also perfect squares. So 15 and 3. 15 times 3 is 45. However, 15 and 3 are not one of our perfect squares. So you don't want to use 15 and 3. All right, so which one of these perfect squares is also a factor of 45? Well, it's 9 and 5. The square root of 9 times the square root of 5. 9 times 5 is 45. So the square root of 9 times the square root of 5 is also equal to the square root of 45. And then simplify. The square root of 9 is a perfect square. The square root of 9 is 3. So our simplified answer, instead of the square root of 9 times the square root of 5, we'll write it as 3 times the square root of 5. And that is your simplified form. So it's just as easy as, going through your list of perfect squares and figuring out which ones also go into that number. Let's look at another one. Say we have the square root of 72. So again, run through your list. What numbers go into 72? The most common one that people pick is they think, and this is right, they use the square root of 9 and the square root of 8. Okay, 9 times 8 is 72. Okay, that's right. And 9 is also a perfect square. So this is good. So the square root of 9, same as the other one, square root of 9 is 3. So we could rewrite this, instead of the square root of 9 times the square root of 8, we'll write it as 3 times the square root of 8. But we're not done yet. Okay, so this is right. The square root of 72 is equal to the square root of 9 times the square root of 8, which is also equal to 3 times the square root of 8. But 8's not a prime number. 8 has factors too, and one of 8's factors also happens to be a perfect square. So you could break this down even more. Okay, the square root of 8 can be rewritten as the square root of 4 times the square root of 2, because 4 times 2 is 8. Okay, and then that 3 still stays out front. And again, these are all equal to each other. All right, so now we're down to 3 times the square root of 4 times the square root of 2. Okay, well, the square root of 4, of course, is 2. 2 times 2 is 4. So now what we have is we have 3 times 2 times the square root of 2. And then a number times a number, just with x, same as the exponent properties. Anytime you have a number times a number, you just multiply them. They're just numbers. 3 times 2 is 6. And then square root of 2 is prime. Okay, you can't break down a prime anymore. So our simplified form of the square root of 72 through all these steps is 6 times the square root of 2. Now there is an easier way to do this one. This is the most common way though. You're trying to think of factors of 72, 9 times 8, your times table is 9 times 8 is 72. So you start with that, and that's fine. If you're starting with that, just make sure that you can't break down your radicals any further. Okay? Because if you would have stopped here, you wouldn't have gotten it right. Okay, because 8 goes down further. Okay? So a good rule of thumb is to try and break it down into prime numbers. Okay? 3 is a prime number, 8's not a prime number, so you could break that down further. Now some people would have noticed that 9 does go into 72, but there is a bigger perfect square that also goes into 72. Okay? And if you're able to find that, this problem became a lot easier. So 72 has a lot of factors. One of the other factors of 72 is, instead of 9 and 8, which is a factor, another one would have been 36 and 2. The square root of 36 times the square root of 2 is the square root of 72. 36 is a perfect square. It's 6 times 6. So this one could have been a little easier if you would have gone through more of the factors. The square root of 36 is 6. Square root of 2 is 6 square root of 2. So you end up with the same answers. Again, one's a little more efficient, But, even if you pick, not the best factored pair, you could still get down to the right answer. So both of these ended up with the same answer, just one couple fewer steps. So we'll get one more. So we're trying to break down we're trying to simplify the square root of 30. All right, so again, do what we were doing. Start to think of factors of 30. Well, what are some of the factors of 30? Well, you got the square root of 15 times 2. Yeah, but those aren't perfect squares. What else goes into 30? 10 and 3. Square root of 10 times the square root of 3. But once again, those aren't perfect squares either. So what else? 5 and 6. Square root of 5. Square root of 6. Okay, these are all right. They're all equal. But none of these are perfect squares. Which means there's no perfect square that goes into 30. Okay, these are all the factors of 30. 15 and 2, 3 and 10, 5 and 6. None of them are perfect squares. Which means the square root of 30 doesn't simplify. The square root of 30, even though it's kind of a big number, doesn't have any perfect square factors. So the square root of 30, you can't simplify. You just would have to leave it as a square root of 30. That's as small as that radicand can get. So not every square root, not every radical is simplified, can be simplified. So some of them can't be. And again, 30 is a weird one where it's kind of a big number. It has a lot of factors, but none of them are the perfect squares. So that's an option too. But again, break it down. Think of all the factors. More specifically, try and think of ones that are perfect squares. And if you can find the biggest perfect square, it'll make it a little easier. But you don't necessarily have to. Yeah, and then break it down. Okay, so again, we're trying to get that radicand as small as possible. A lot of times you end up with a prime number under the radical, but that's not always going to be the case. Okay, so those are the notes we missed or we didn't get to finish in class. I told the other class I would show them one more different example that we hadn't done. So let's do one more just for fun. Let's do the square root of 98. All right, so this one's weird because like 98's kind of a strange number. What numbers go into 98? What perfect square goes into 98? It's kind of hard to tell. So one thing, if you're having trouble trying to think of perfect square factors that go into the number, you could just try a couple. 4 doesn't work. 9 doesn't work. 16 doesn't work. 25 doesn't work. So if you're having trouble trying to find that perfect square, just break it down into smaller numbers anyways. 98 is an even number. So we know 98 is divisible by 2. So you could start off by doing the square root of 2 times, and then figure out what 98 divided by 2 is. So 98 divided by 2 is 49. So even though I didn't know that right away, now I realize, 49 is a perfect square. So again, you can kind of just guess. It doesn't always have to be a perfect square on the first breakdown. Okay, you could kind of break it down into one that you know, and then maybe a perfect square will pop out. So on this one, even though I wasn't sure that 49 went into it, I knew 2 did. And then I did 98 divided by 2. I got 49. And I know that 49, the square root of 49 is 7. That's a perfect square. Okay. So now I'm left with square root of 2 times 7. And then you always want to write it with the number part first. So we're just going to slide that 7 to the front. And then have the square root of 2. So one last example. But again, try and think of perfect squares. The factor can't be bigger than the perfect square. So 98, you can just try all the perfect squares 1 through 9 and figure out which one it is. But again, it is possible that you can't break it down, or you can't break it down into a perfect square, just like in that case with the square root of 30. All right, so that's the first method for simplifying radicals. Tomorrow we will do the other method. Okay, and both methods work. You can kind of pick and choose what you want.